name is Rod Kawecki. What we're talking about in this video today is two discrepancies, actually three. My name is Rod Kawecki. As you see, I've written several books on space relative to Einstein's theory, because his theory seems to be the leading research and listed in today's literature in the United States, worldwide. But the discrepancies I'm talking about in the development of my theory, which is the quantum physics theory, there are several, but as you see in the diagram, we're talking about a flat universe, a round universe. Einstein said that the universe was flat, and therefore it floated. What he's talking about is a flat universe, like they thought the Earth was flat, is a 1 and 2 dimensional space. The third dimension, Edwin Hubble discovered in 1943 that the universe was expanding. It was getting bigger. Matter wasn't expanding, but space was being filled in. And I could only find one explanation that could satisfy that question of why it is filling up between the galaxies. And in the quantum physics theory, that energy is called concentrated energy, which means, in the beginning, you might have viewed a couple of my earlier videos, that the universe, at the time of the Big Bang, and it explains in there, in a zero-point energy space, such an explosion would create a void in the center of that 360-degree bang. There is where the change of the space equivalent element changed. It became concentrated. It followed the same routes as matter did when it exploded, when it broke down, when it stretched to its ultimate limit, and then recurled into itself. Space, reluctantly in the same category, became concentrated. That concentrated space is where the galaxies in Hubble's theory cling to. An invisible void of which is also rotating. As you can see from the next diagram, we're talking about Einstein's flat space theory, straight line, two-dimensional, with a spin, which means a vortex. That's where the vortex came in. And on the other side of this diagram, we have a round, three-dimensional universe. This is one discrepancy. I also have the mathematical formulas relative to the speed of light, relative to its length. Here's a diagram of what the universe might look like. You can see in the center is a bubble, Stephen Hawking. In string theory, we have Michio Kaku, who believes that the universe, if it was able to be observed from a further enough distance, that this would be what it looked like. And if you look at the center, that blue part, that's concentrated space. So, me and Michio Kaku do have something in common. His picture, his idea, what it might look like, but he doesn't have the theoretical idea, literature, and equations to show its examination. in space, we have a specific order about things, and the best way to show that is our solar system relative to the masses that are around it. We also have here a video picture of what a 3D universe looks like as you measure length. The expansion of the universe relative to 13.5 billion years. So when we talk about gravity, whether it's a 0-point energy gravity, which is empty space, or a 9.8 meters per second energy, like on Earth, in space we have this concentrated change of the element. It becomes concentrated, which means it becomes an element relative to itself, yet it retains no signature for energy. Why? Because of its fabric condition. It's not organic. It's not made up of matter. It's made up of something else, but yet it's concentrated. Its form changed in the beginning relative to what happened at the day of the Big Bang. Based on this new idea in quantum physics theory, E equals V. G, of course, is gravity. V is the velocity, and energy is the ability, is the amount of energy that would make it possible relative to the difference in the gravity field, where there's a condition of gravity in space, 0-point energy, relative to what we measure here on Earth and its gravity. Yeah, on this next upcoming diagram, I'm showing a picture of what matter does to space. It pushes it down, it pushes it around, and it causes it to move. Here's another book that I've written, The Celestial Universe. I've written over 5 books on space, my research over the last 20 years. I think I've written enough to where I have a new theory, the quantum physics theory. In essence, we're talking about relativity, a flat universe, a Hubble universe, matter, and the possibility of matter actually expanding in its own prevents. And then we have space expansion. My name is Kawecki. Thank you very much.